Hi, today I'll be talking about multimodal AI models. Typically, in the past, we have had different models being used for different capabilities. As an example, I am showing if we wanted to segment out the cat, we would have perhaps used a segmentation model. Or for text-based tasks, as an example, if we have to do sentiment analysis, we might have used a different model. For understanding charts, we might have used a different model. But in today's day and age, there is a bunch of these frontier models which are inherently multimodal, which means they can handle these multiple modalities, including video, audio, images, text. So today I want to be talking about one such very good model, which is Gemini 3 Pro and its other variant, which is also used for generating images. Through this talk, I will be showing how we can pass an image like this and then get a segmentation and a lot of other tasks. I'll very briefly show the details required to set this up. So we require a Gemini API key, which one can get through the Google AI Studio. And you'd have to then export it as the environmental variable. The documentation for Gemini as well as Google AI Studio is fairly good. So I'll skip all of those. And I want today's discussion to be more focused on the applications and the use cases as opposed to the details of the code and the setup. So I'll have the regular imports. Importantly, the environment variable, we'll have to check whether it's properly set or not. I'll be using two different models today. The first one is going to be Gemini 3 Pro, and this is in the preview mode. And I'll be using a Pro image model to generate images. So using the API, we can also list all the available models. We can also see in the pricing, some of them are comparatively cheaper as opposed to 3 Pro and 3 Pro Image, which are the state of the art and thus a little more expensive compared to some of the earlier ones. I have a bunch of helper functions which we can skip for now. So the simplest way to get started is to create this client object. So if we go back and look at this initialize this client using the SDK provided by the GenAI library from Gemini. So we provide the API key, we create a client object, and then if we wanted to do a simple task of, say, answering this question, what is the capital of France? So we call this client.models.generate content. We need to give the model. I am giving the model as Gemini 3 Pro preview and this question, and then the answer I get is in the response.text. So this is if you wanted to give a single request. So another important thing, many of these things which I'm discussing could be done via, let's say, ChatGPT-like interfaces or Gemini-like interfaces. But I wanted to show the usage of API, which can help us do things at scale and programmatically. So if this was one question, if we wanted to answer multiple questions, we can just create a list of these. And then for each of them, we could call the same function as earlier. So in this task, I'm showing the translation of two words in different languages, in Spanish and French. And again, we can just print out the results and see that the model is doing is fairly good in answering such questions. So we have already seen that it can answer questions related to certain general knowledge, I would say, the capital of certain countries. It can translate. So it is already showing strong capabilities across two different text tasks. Another important task is to analyze the sentiment. Perhaps if there are Amazon reviews or something similar, we want to generate some sentiment around that, or we want to understand the sentiment around some text on the social media. So we give in a text, we get in its response as either positive, negative, neutral. This specific case is a case of zero shot. We have directly just given the prompt and we are asking the response corresponding to it, the sentiment corresponding to it. There is another variation for this, which is just few shot classification. This becomes useful for your specific application, as in if you want to classify customer services queries into categories. Perhaps if we have an IVR system and people are recording their queries, so we can see that whether we should be sending that query to tech support, billing, general inquiry, complaint, or account management. We have given some examples. So this becomes a part of the prompt where we have given these examples. And then when we want to test, we just give a specific query and we can see that it's fairly accurate in telling, like the app keeps crashing, should be tech support. You charged a premium on a free plan, should be billing. Shipping should be sent to shipping. Product arrived damaged, as well as so it's a complaint. So another kind of a task. Another popular machine learning / NLP task is named entity recognition. So you want to get the entities such as in this para, you want to get the entities such as name, organization, location, money, date. So for a human being, it would be quite trivial to do this. We can again have purpose-built models, but this is the beauty of having these highly capable multimodal models, that we can, for the same model, we can get we can get output very accurately across multiple tasks. So we have been able to extract a JSON through this, which you can now pass into your further pipelines. Another task is to summarize text. So we can give the prompt as in to summarize this in one sentence, to make it into a tweet, etc. So we can also see how the prompt is being passed. So we're passing in the content as the prompt type and the article. So the prompt type would be summarize in one sentence, and then we give the article. So all of this becomes a part of a one large string, which is being passed into the model. And we can see that the response is quite good again. So this is telling a 3-point bullet point summary of artificial intelligence. This is a tweet length summary. Similarly, we can answer complex questions. So we first given the context about the Eiffel Tower, it was built during this year, about made from this, etc. And then if we ask in certain kinds of questions, how tall is it, what material is it? So we can again see that the answers are quite accurate. So the model is capable of searching in the text and figuring out the correct answer. We can also do translation across different languages. So artificial intelligence is changing the world. I was particularly interested in also seeing how it is translated in Hindi. So languages such as Hindi are perhaps lesser, I would say lesser accurate in many of the models as compared to perhaps English and Spanish and French. But this response seems quite accurate. So it says Kritrim Buddhimata Duniya ko badal rahi hai, and which it's breaking down and also giving the the phrase-wise translation. And next I wanted to check certain more complicated tasks. Now I would say the text tasks seemed to give a very good response. Now we wanted to see how the performance of such kind of models is on certain vision tasks. So object detection is a standard task in vision. So we give this particular image. Now I am asking the model to tell me the cat's left eye, left ear, right ear, and the body. Now typically in such tasks, object detection like tasks, so we create something known as bounding boxes. For them we need the coordinates of the left, let's say the left corner, the right corner, and something of that sort. So this is what we'll say to the model to return. A JSON array which returns a label and a box 2D mentioning y min, x min, y max, x max in certain ranges. So this is what the model is able to return, and then we can use some libraries to visualize this. So if this is the original, okay, for some reason I think my code for this is not yet here. But we come back to this later. Perhaps for now we see the image segmentation. So this is a similar kind of a task as previous, but now I'm not asking for bounding boxes. I am asking to give me the polygons. So in the meanwhile, so let's just see this polygon task, and we can see that. So I've asked, so there are multiple ways in which I could get the image segmentation. I could ask it to return a binary mask. In this case, I'm asking it to return me a polygon. So similar to a path being returned. So this is the response that I get from the model. Again, I'm using certain matplotlib functions to help me visualize, and we can now very neatly see this visualization that the segmentation mask is quite accurate, and this is with the overlay. Again, this would seem very unreal if we were told a few years earlier back that a single model could do segmentation, object detection, text tasks, vision tasks. So it's quite unprecedented. And now we'll have some more fun in this exercise. So I took some handwritten notes where I had some notes for my machine learning lectures where I was introducing linear regression, and we were trying to compute the normal equation. So this is the starting setup that I've given, and I asked the model to take this image, which is, I've called it leastsquares.jpg, to take this image and then identify the mathematical concept, solve the problem, explain each step, provide the final answer. So I've given in now this prompt as well as the image. So therefore now you can see that the model is capable of taking in multiple kinds of modalities as inputs, in this case text as well as image. So it gives in this very nice response which seems correct, and it's also rendering the maths in LaTeX. Now I wanted to take it a bit further. I also now wanted to say that let's use an image model and somehow complete this on a whiteboard. This proof on a whiteboard, this derivation on a whiteboard. And I've mentioned that write on white cream paper, mathematical notation, different layouts, handwritten field, include diagrams, and a particular ring style. So if we now look at the rendered drawn image, so if you can see, it looks quite neat, quite accurate, although it looks significantly better than my handwriting. So it would be still quite easy to see whether someone like me has written it or it's an AI system which has written this equation. But this was to show the capability of image generation. We can further now take in images and answer different kinds of questions. So if I'll first show an image. For this kind of an image, we are asking questions like, what is the dominant color? Describe the scenery. So it seems to be, again, fairly accurate. High altitude alpine, landscape, twilight, either sunrise, sky, talking about the mountains, the sea of the clouds, the foreground, etc. Another different kind of task is where we have some structured data being plotted. In this case, some charts. So if we have these bar plots and these line plots, we can pass in this as an image and ask questions like, what are the trends you're seeing? Which month had the highest sale? So again, these are the kinds of questions which downstream applications might use, or if you're trying to get certain insights out of these images or plots or charts, that these are the questions you might want to ask. Again, the responses are very impressive. So monthly sales 2024 chart shows overall positive upward trend. Growth isn't perfectly linear. There are slight dips in March and May. So there are slightly dipping in March and May. So it's able to accurately understand the trends of the charts. Another one is capability is to do OCR. To simulate OCR task, I created this fake bill. Again, just use simple Python syntax and created this kind of a bill. And I gave in this bill as an image and asked the questions, can you get me some structured data out of this, including store name, receipt number, list of items, total amount, and the payment method. And now I'm giving in the image as well as the text prompt. And again, it seems to be able to recover what I had initially created, like the Acme store 123 Main Street. It's able to very accurately get in that specific structure. Now things get more interesting. I had this specific video where this old person was walking and there were some animals. Now given this video, we ask, so we also have to upload this video using this client.files.upload API. This is slightly different as opposed to how we were directly using the images. So once we've done that, we pass in the similar kind of an API. We call in the API similarly, prompt and the video file. And now we are giving this particular prompt, describe what happens in this video and what do you see. This was again pretty impressive, quite seen on a cobblestone path, old stone building, elderly man walking away from the camera dressed in grey blazer. So I personally not noticed all of these things. So it was very impressive to see that the model was able to capture all of these details quite accurately. If we extend this further, we can also do certain kinds of action analysis, like list all the distinct visual elements in chronological order as they appear. So now we want to get time and then what is happening. So if we notice there is an elderly man, chicken, cobblestone path, and then there's a rooster, etc. So it's able to get in the time and then what is happening during that in a chronological order. So again, pretty useful in varieties of downstream applications. We can further pass in a different modality, which is the audio. So I took in a Gemini blog post and I converted that text to speech and I passed in that speech here.
Gemini is Google's latest multimodal AI model, built to understand it.
So if I give in this specific model, this specific data, audio data, I again similarly to the video upload this, and then I give in the prompt as describe this audio exactly as spoken, transcribe this audio and include any speech, sound, etc. It was again fairly accurate in getting me the correct transcription. Now, one of the other fun aspects of these kinds of models is image generation. So here I wanted to create an infographic for transfer learning where I'm telling about the pre-trained model, transfer, fine tuning, and telling about the color schemes, etc. Here I'm using a different model, the image model, which is the Gemini Pro 3 image preview. And this is the infographic that it's been able to create. Again, in a matter of seconds, it's able to create very beautiful, technically correct infographic. Now, this was one way to create images where we call in the image model. But let's say if we wanted to create a simple logo, we could either do it via an image model, or in this case, I'm actually asking the regular model, which is just the Gemini 3 Pro, to create an SVG, which for a logo for a research lab called Neural Insights. And I'm giving in certain requirements. So once I get in the SVG, I'll have to do a bit of parsing to get the correct SVG characters, and then I can render it. So again, it seems like a very good first rendering of what I wanted. Another important kind of task is to get an understanding of spatial reasoning pointing. So we have created a fairly fake kind of a data here showing different objects, and so it was meant to mimic table and certain things kept on a table, etc. But because we didn't use an actual image, this is quite a simple kind of a drawing. So here we can ask questions like list all the objects, tell the position relative to the other object, above, below, etc., which is the highest object. So again, it's fairly accurately being able to tell that red rectangle, there's a red rectangle, brown rectangle, green rectangle, there's a blue shape, which is an oval shape, and there seems to be a yellow lamp. Then the positions, the blue rectangle is at the bottom of the image, the red rectangle is floating above the blue. So it's able to quite accurately get the relative positions. Again, quite useful for various kinds of downstream tasks. The PDF functionality is quite well known in today's age, but I anyway for completeness wanted to show this. So I had this paper which we had published in 2014. So I gave in this PDF and I have then asked our model. I've passed in this, uploaded this PDF again via client.files.upload. I'm asking questions like what is the type of the document, the main section, summarize in 3 to 4 sentences. So it's quite accurately again able to get all of the responses, as well as if I give in multi-page PDF extraction. So I gave in questions like, can you tell me the authors? Can you tell me the main sections? So I verified it seemed to be correct. Another kind of a task which we've shown to some extent earlier also is to try and get a structured response out of unstructured information. In this case, if I pass in a text, I want to get in the information like with a particular schema in mind, name, age, title, company, location. So it's able to very accurately get the structured JSON also. Now, many of the previous things that we have shown, they will perhaps not be able to fetch in the latest data. For that, we require to enable certain kinds of additional tools. In this case, we are enabling the Google search tool. So this can enable us to answer questions which are the latest information, like the latest developments in AI this month and who won the latest Nobel Prize in physics. So such questions will not be answerable by the methods, by the models, which have a certain cutoff date, which is perhaps prior to when these events have occurred. So therefore, we need to have the search grounding like tools available. There are different other kinds of tools also available, including function calling, which is particularly useful for agentic workflows. So here I just wanted to show how we have just modified the config to include this new tool, and we're asking these questions which we had done, kinds of questions like the latest Nobel Prize winner in physics. And I was very pleasantly surprised to see that the latest developments in AI was fairly accurate. So it tells that today is December 6, 2025, and it is telling about Gemini 3, Nano Banana Pro, Mistral AI, which was released 2nd December, then DeepSeek December 1, then AWS event, OpenAI GPT rumored 5.2, as well as for the physics prizes. Also, it's able to get the awards which were given in October. So overall, if we see that so there are some artifacts from the previous block, some from previous code which I have not yet removed. But importantly, if we conclude from this discussion, we can see that the multimodal AI models are very powerful. We have seen the usage and the capabilities across different modalities, including text, vision, audio, as well as searches. So we can also do different kinds of tool calls. So it's an interesting time to be having these different models and the capabilities, and I believe they unlock a lot of potential. Thank you.